Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on VLSI technology. Today is the 18th class of this lecture series. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. सब्सक्राइब की बेल आइकन को प्रेस करके रखिए ताकि जब भी मैं कोई नई वीडियो लेकर आऊँ आपको पता चले. So let's get started. Welcome to VLSI Technology Series. In previous class of this lecture series, we discuss about the electronic grade silicon and how we process it. We talk about this. Okay. In today's class, we talk about the point defects of silicon wafer. Unfortunately, in real life, nothing is ideal. So, in today's lecture, we discuss about one of the defects of crystal wafer, that is point defects. Okay. First of all, in this slide, we discuss about the crystal properties, that is the processing characteristics and some material properties of silicon wafers depends on its orientation. First point is the 111 planes have the highest density of atoms on the surface. Right. So, crystal grow most easily on this plane. Okay. Second point is the tensile strength are highest for 111 directions. Third point is 111 planes oxidize faster than 100 plane. Why? Because 111 plane have more atoms per unit surface area, which is available for oxidation reaction to occur. Right? That's why bipolar circuits have preferred 111 oriented material and MOS devices are preferred 100 oriented material. Okay. So, these all are of course expectation, but real scenario is different. In this lecture, we talk about this ideal versus real scenario of the crystal wafer. Okay. So, what is the defect which is not ideal or perfect? Right? In all our discussion so far, we have assumed ideal crystal. That means it is a perfect crystal. First question, what is the crystal? Crystal is a regular arrangement of atom or regular array of atom. Okay. We have assumed that this array of atoms are perfect. So, it is an ideal crystal. But in real life, nothing is ideal. That means a silicon single crystal is not also an ideal crystal. Right? Second question is, what about the surface? The surface means there is a loss of crystallinity on one side. Right? Some of the atomic bond is missing on the surface, which brings us to defect in the crystal surface. Okay. Third question is, what are the common defects in the crystal? How this will affect the electronic properties of the material? Can we stay with this defect? Which material is suitable for integrated circuit fabrication and which material is not suitable for integrated circuit fabrication? We discuss all this topic. Many types of defect we discuss in this lecture series. First one is the point defects. Okay. That means These are isolated defects scattered inside the crystal. That means point defect means this is a isolated defects scattered inside the crystal. In next slide we talk all types of point defects. Okay. In this slide we talk about the point defect. First type of point defect is vacancy defect. Okay. Vacancy defect or Schottky defect. Okay. We already know that crystal is a regular array of atoms. In this crystal structure, when one atom is missing, in this figure this atom is missing. So when one atom is missing, this missing atom create a vacancy in the lattice, which is called vacancy or Schottky defect. This is one type of point defect. Okay. Second type of point defect is substitution impurity. We know impurity atom is doped into the silicon crystal. Any non-silicon atom, when incorporated into the lattice at substitutional site. What does it mean? This is a non-silicon atom. This dark green ball, green color atom or green color ball is non-silicon atom. This non-silicon atom incorporated into the lattice at the substitutional site. That means this non-silicon atom replace the host silicon atom. These all are the host silicon atom. This atom is the non-silicon atom and which is replace the host silicon atom. This was the another type of point defects. Third type of point defect is interstitial impurity. We know impurity atom is doped into the silicon crystal. When any non-silicon atom incorporated into the lattice at the interstitial site. That means when a non-silicon atom, this green color atom or this green color ball, when this non-silicon atom appear between silicon atoms and defect the lattice structure, this is also another type of point defects, which is called interstitial impurity point defects. Okay. Fourth type of defect or fourth type of point defect is self-interstitial impurity. We know impurity atom is doped into the silicon crystal when any silicon atom incorporated into the lattice at the interstitial site. That means, just a minute, this is also a silicon atom. This silicon atom appear between this silicon atom. This is regular arrangement of crystal structure. This silicon atom is appear between this silicon atom and defect this lattice structure. This was the another type of point defects and it is called self-interstitial impurity point defects. Fifth type of point defect is called Frankel defect. Okay. When a silicon atom in an interstitial lattice site with an associated vacancy is called Frankel defect. That means here one silicon atom is missing and here one silicon atom is appear between two silicon atoms. So this interstitial impurity type of defect plus one vacancy defect when present in a lattice structure, then this defect is called Frankel defect. So these all are the 5 types of point defects which I will discuss in this lecture series. In next class, we discuss about some more of the point defects, some more advantage, disadvantage of the point defects. Okay. So, here we end today's session. Thank you. If you like my video, then please like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.